Hey everybody. Today we're talking about statistical significance in hypothesis testing. So a statistical hypothesis test quantifies how plausible a particular parameter value is in light of sample data. And it does that by producing a p-value, which expresses the probability of getting a sample statistic at least as extreme as the one you actually observed, assuming that hypothesized parameter value, the null hypothesis value, is true. So lower p-values represent stronger evidence against the null hypothesis, in the sense that the lower the p-value is, the less plausible the null hypothesis is. You should always report your p-value at the end of a test because it describes the weight of the evidence against the null hypothesis, but at the end of the day, you typically have to make a binary decision about whether to reject the null hypothesis or not. And it's best practice to set a threshold for rejection before beginning the test. The threshold is called the significance level of the test. The most common level for that is alpha equals 0.05, but that value is not universal. There's nothing magical about that value. That's just a number that is thought to strike a reasonable balance between false positives and false negatives in your hypothesis tests. If at the end of the test we get a p-value that is less than that threshold alpha, we reject the null hypothesis and say that our results are significant at level alpha. An example. The manufacturer of a certain brand of chocolate bar advertises that, on average, their chocolate bars weigh 350 grams, but I worry that this is an overestimate. So, I have a null hypothesis of mu equals 350, the parameter value I'm interested in, and an alternative hypothesis, mu less than 350, the thing I'm actually expecting to gather evidence in favor of. I want to test at significance level alpha equals 0.05. So, suppose we go out and get a random sample, compute a sample mean, and get a p-value of 0.0089. Since this is less than the threshold we set, alpha equals 0.05, we reject the null hypothesis and conclude that in fact the average weight of the company's chocolate bars is less than 350 grams. We say that result is significant at level alpha equals 0.05. Now, although we concluded that the company's chocolate bars do weigh less than 350 grams on average, there's still a chance that we're wrong. In fact, if the null hypothesis were true, we would still obtain a sample like this, in the sense that X bar would be at least as extreme as the one we observed, about 0.89% of the time. So, viewed from that perspective, the significance level of a test encodes how tolerant we're willing to be of that kind of error, what we'll eventually call a false positive or a type 1 error. Another example, a mill produces boards that are supposed to be 80 centimeters long. As part of their quality control process, they gather a random sample to check that their machines are calibrated properly. So here the null hypothesis is that the average length of all their boards is 80, and the alternative hypothesis is just that it is not. They test at significance level alpha equals 0.01. Suppose at the end of the process they obtain a p-value of 0.023. Now, they were testing at significance level 0.01, and p is greater than 0.01, so they do not reject the null hypothesis. They do not have evidence that the machine is miscalibrated. Notice it would be wrong to conclude that the machine is calibrated correctly here. If the machine were calibrated correctly, they would only get sample data like what they got about 2.3% of the time, so not very often. It's just that the weight of the evidence doesn't rise to the threshold that was set at the beginning of this process. Finally, notice that this conclusion would have been reversed if the company had chosen a statistical significance level of alpha equals 0.05, because the p-value is lower than 0.05. If that had been their significance level, they would have rejected the null hypothesis and concluded that their machines needed to be calibrated. This really underlines the importance of reporting your p-value, the weight of evidence against the null hypothesis, and not just the binary decision that you get based on the significance level alpha. Because at the end of the day, whatever significance level you choose is ultimately arbitrary.